Hi, everyone. So I'm Steven Terrana. I was lucky enough to be sitting next to Michael last night. So I work at Booz Allen Hamilton. We're a federal consulting firm. So my day-to-day life involves working with different government agencies to help modernize legacy IT systems or help develop new ones. So this is actually the perfect talk to follow up what we just saw around some dangers in your Kubernetes configurations. And today we're going to talk about building trusted software supply chains. All right, so how do we get applications onto our clusters that are as secure as they can be by default? So today we're going to talk about what does DevSecOps actually mean, walk through a couple different kinds of security testing that you can integrate, and then we'll talk about what I've been working on the last couple of years for how we implement this at the enterprise scale. Next slide. So this is probably the most important slide in the deck that I have. I talk to a lot of different people about DevOps, and I've never spoken to any two people that have the same definition. So this slide serves to level set on what I mean when I'm talking about DevSecOps. So in general, the DevOps cultural transformation, if you will, was about getting application developers and operations engineers to work together more effectively through things like infrastructure as code, automated testing. And in large part, that was successful. We can now reliably and confidently build, test, and deploy our applications. But maybe specifically in the federal space, but I'm willing to assume this applies more generally, we were still seeing a pretty significant bottleneck when it came time to actually releasing software out to production for our end users. And that's because we left out a very important team. At no point had we pulled in the security team to see what the requirements were to be allowed to release our code into production. So enter DevSecOps. And DevSecOps, if you take away one sentence from the next half hour, it's that DevSecOps is all about incorporating security into every step of the software development lifecycle and shifting it left as much as possible to make sure that the security teams at your organization have their requirements reflected in the automated processes to get your applications from your laptops out to end users in production. So there's 6 different boxes there. I'm going to go through each of them in a lot more detail and sort of talk about what is it, why do you actually care, and what are some common tools that I'm seeing folks use to implement this. So first up is application dependency scanning. So we're all building applications. Most of us have not written every single line of code that goes into our application, and that's because we're pulling in third-party application dependencies. These frequently take care of common coding problems that it's not worth the time for all of us to code individually. The challenge here is that because we didn't write that code, there's frequently vulnerabilities. That's sort of just how building software goes. The real problem, though, is when you don't patch these vulnerabilities. Right? So you'll start a project, you'll pull in sort of the boilerplate, React starter or Spring Boot starter API, and you get a dependency list, and you never patch it. Years go by, you have a very full backlog, understandably, and upgrading the versions of these application dependencies never seems to be the highest priority. So if we're talking about our DevSecOps pipelines as a trusted software supply chain, you can think of these application dependencies as the ingredients that are going into building your application. So application dependency scanning is all about how do we scan these to make sure that they don't have known vulnerabilities, right? So another challenge is that these are changing every single day. It's very likely that new CVEs are being released that are exposing our applications to security vulnerabilities. So how do we actually go about fixing this? One best practice is to leverage a centralized artifact repository and do some actual scanning on these dependencies. So a tool that I've used and am fond of would be like Nexus. Nexus, which is an artifact repository. The idea here is that instead of pulling your dependencies directly from the internet, you can store these in a centralized artifact repository. As artifacts are being pulled into your environment, you can scan them to see if there's any known vulnerabilities against them. And then the first day that you pull in a dependency, it might be secure, but tomorrow it might not. So having all of the dependencies that you're using in a common place lets you continuously scan what's in your environment so that you can generate a bill of materials that represent the ingredients comprising your application. So let's assume we did that. We know that all of our application dependencies are secure. We're not pulling in an old structs package that's going to expose the organization. Next up is actually scanning the code that we've written to make sure that it doesn't have any inherent security vulnerabilities. So that means, did you hard code IP addresses or passwords? So why does this actually matter? The first is it can assist a lot in code review. These tools can help you from a security practice perspective, but it can also help from some of the industry standardized best practices so that when you're doing code reviews on your applications, you can focus on the aspects that are specific to your team and allow these tools to automate the quality of, you don't have dead code in your application that's ever actually going to be run alongside those security bugs of, you're not hard coding IP addresses that Ian can go find and then hack the application. Some common tools to do this. SonarQube is one of the most popular. There's Fortify. There's a whole bunch of different tools that can scan the code you've written to make sure that there aren't inherent vulnerabilities in it. So up until this point, we've made sure that the ingredients in our application are secure. We actually wrote some code, and we scanned it to make sure that the code we've written isn't inherently insecure. So next up, we are a KubeCon. So I would assume that a lot of us are building containerized applications. So now that we've written code, we want to package that, pulling in those application dependencies into a container image. This is a new artifact, so we need to scan it. We need to make sure that if we're just pulling random images from Docker Hub, make sure that there aren't crypto miners on there, making sure that there aren't vulnerable OS packages in our container images. So why does this matter? It's the same thing as application dependencies if you're pulling straight from Docker Hub. You don't know exactly what went into building that container image. So what can you do to prevent this? There's some tools out there that can do some container image scanning. If you go into the vendor hall, there will probably be about 604 container image scanning tools that you can choose your favorite. And what are some best practices to help with this? So a lot of what I do is, my day-to-day is being on a DevOps team that's supporting multiple application teams simultaneously. A lot of application developers would prefer to just write code and not necessarily be concerned with how does my code turn into a container image, how do I write a Helm chart to deploy that onto Kubernetes. So when it comes to choosing base images, one thing that I've seen be successful is to have your centralized platform team or DevOps team actually manage some gold images that the application developers can start with. So instead of just going out to Docker Hub for every team and choosing the latest thing that seems like it does what you want, you can sort of curate some starting points for the application development teams in your organization, and then continuously scan those and be responsible for patching them so that you can sort of offload a lot of that responsibility from the application teams. When you do that, it means that the application developers now have a much smaller boundary of control that they're responsible for. If they're inheriting all of the patches from this centralized base image, then they're only responsible for patching their application dependencies or whatever they're customizing on top of that base image. So security vulnerabilities in general come in two flavors, right? You have vulnerable packages. So we pulled in an insecure ingredient into our application, or we pulled an image from Docker Hub that has crypto miners on it. But there's also configuration errors, which we saw a whole lot of in the previous talk. So a lot of those container image scanning tools that we're using to scan our container images can also scan the configuration of the infrastructure that we're building, whether it's the underlying hosts or your Kubernetes cluster or the configuration of a container image to make sure that it doesn't have known vulnerabilities. So being a federal consultant, there are a lot of federally regulated guidelines on how you're supposed to build and deploy infrastructure. So things like secure technical implementation guides, NIST guidelines, FISMA compliance. So if you are working in that space as well, a lot of these scanning tools have specific rule sets or profiles aligned with these different federally regulated policies. And that can be very helpful. If you're developing software in the federal space, you need to acquire what's called an authority to operate, which means that someone is taking responsibility for your application and saying that if something bad happens in production, I'm responsible for that. And understandably, they are often wary to do this. So making sure that what you're building and deploying complies with all of the federally regulated guidelines can greatly accelerate your acquisition of an authority to operate. So up until this point, I'm going to keep repeating it because it's important to remember that all of these steps put together are what result in a trusted software supply chain, right? Just like if we're building a car, we want to know where all the different pieces are coming from and who's manufacturing it. The same thing applies when you're building your applications. So up until this point, we've made sure that the ingredients of our application are secure by leveraging a centralized artifact repository and doing application dependency scanning. We then wrote some code, and we made sure that it's secure by doing some static code analysis and making sure we're not hard-coding IP addresses or otherwise writing code that's going to leave us susceptible to exploitation. After that, we built an artifact in our container image. If you're working in a large organization, it's likely that there's a centralized team that helps with that, and they might help you manage a gold image that has some security configuration set up or help you with patching of that. And then we scanned it, right? So with continuous compliance, we're able to then scan that container image to make sure that we're not running it as the root user, make sure it's compliant with the different security profiles that help enforce some of these security configurations so that you can't get root access to the underlying host as easily as we just saw. So at this point, you can now actually deploy the application and make sure it's not susceptible. So dynamic application security testing is a mouthful of a way to say penetration testing. So we can actually deploy our applications and make sure that they're not susceptible to common exploitations. You know, if you have a form, is there a way for me to do arbitrary code execution? Things like that. So a common tool to do this is OWASP Zap. It's open source. There's a whole bunch of other tools that can help out with this. And why does this one matter? Because everything up until now, we hadn't actually deployed anything. So penetration testing is how we can actually start to attack our deployed applications. So this talk is primarily about the supply chain of our applications, but another good tool or practice that you can be implementing is like continuous security monitoring of your clusters, right? So there's the CNCF project Falco. So if you have that configured on your cluster, it can be monitoring all of the different kernel or commands that are happening on your node. So if you're running penetration testing and you have Falco rules configured that can monitor the environment to make sure that only the correct commands or commands that you expect are being executed, it's a powerful combination, right? Anytime you see a new shell open a container, there's probably something you want to be aware of. Either somebody is debugging something or you're about to get hacked. So the pipeline. Everything up until now, there's a lot of different tools that can implement it, and doing them all manually would take a significant amount of time. If all of this put together is in part to help us accelerate our software delivery, we need a way to tie all of that together and automate it. So that's what the pipeline's responsible for. So it's going to orchestrate all of these different software delivery related activities. Basically, when a developer does something in GitHub, what types of automated scans or quality assurance tests are going to be executed. So why does this matter? It helps reduce friction in adopting these practices through automation. If the expectation was for every development team at a large organization to learn how to administer the tools that help you do these things, and then further to go automate it, it's going to be extremely challenging to find time in their sprint capacity to dedicate cycles to learning how to do continuous compliance or fine-tune static code analysis profiles or what have you. So by setting up an automated DevSecOps pipeline, you can reduce friction and accelerate adoption. The second is you can mitigate technical debt by doing this continuously. Another common pitfall is to push security to the right? So you've been developing something for 6 months, you want to release it out to production, and then you go do these security scans, and you find several hundred vulnerabilities that need to be patched before you're actually going to be approved to do that deployment. So by having an automated DevSecOps pipeline, if you're doing this on every single change, it's going to help you with continuously making sure that you're secure. If you open a pull request and you add a dependency to your package.json or your POM file, and you can immediately scan that, it's going to be significantly easier to get that fast feedback and incorporate it than if you wait 6 months and then have to go back and sort of remember the context of why you added that in the first place. So by doing it continuously, that fast feedback can help a lot with fixing problems as they arise. And then again, from the federal space, authorizing officials are those people that are willing to take responsibility for your applications. So if you can communicate to them that every single change is being run through all these different kinds of security testing, it helps them feel a lot more comfortable, and if they're comfortable, they're going to be a lot more eager or willing to do frequent deployments to production. Does anyone work in the federal space? All right, I see a couple hands, so I'm hoping some of these concepts are familiar. I assume a lot of this strict approach to software delivery also applies in industries like finance or healthcare, anywhere that you have like PII or payment data, or really any data. No one wants to go get their data hacked, but especially in the federal space, getting an authority to operate for a new application, if you're lucky, takes 3 months. If you're average, it takes 1.5 years. So by implementing a lot of these practices, you can drastically reduce how long it's going to take for a new government system to be approved and deployed into production. So putting it all together, all of this security testing that we're talking about is in addition to all of the other kinds of automated testing that the industry has been doing for several years. So when you're dealing with enterprise scale adoption of DevSecOps, or you have a diverse application portfolio, which I get to consultants speak for, there's different kinds of apps at your organization. Depending on the application, there might be different tools that are being used to implement each of these different practices. Right? So if you take an easy example in unit testing, if you've got a front-end application, it might be using something like Karma or Jest to do its unit testing. If it's a back-end application, it could be JUnit or Python. Some teams in an organization might be using SonarQube for static code analysis. Other teams might be using Fortify. So the purpose of this slide is admittedly to be a little intimidating. There's a lot of activities that go on in automating a fully matured DevSecOps pipeline. And if you're a central DevOps team that's helping automate these software delivery processes for a lot of different application teams at the same time, a lot of the tools, or actually most or all of the tools in the CI/CD landscape right now are primarily focused on individual applications. You get a pipeline as code artifact that represents as code what your software delivery process is going to be when a change happens. So if you're supporting, let's take an example that I've had to work with, something like 60 microservices being developed by different contractors that are geographically dispersed and using different tools. Managing a DevSecOps pipeline for all of those applications at the same time is extremely challenging, because usually the way that it works is you have a Jenkins file, if you're using Jenkins, that you've copied and pasted and then tweaked to fit the specific set of tools that are being used for any given application. And that's duplicated across all of the source code repositories in your organization. So let's say over time, you want to make a change to your DevSecOps pipeline. You're continuously improving. You've identified something that would make this process flow better. If you want to roll that change out, now you have to open 60 pull requests and modify 60 different pipelines. And from a Booz Allen perspective, as a consultant, we're doing this kind of large-scale support of DevSecOps pipelines at multiple clients. So what we were finding was that within any given client, you've got a whole bunch of duplication with these application-specific pipeline implementations. And then if you zoom out across all of Booz Allen, we've got DevOps engineers in the firm at all of our different client engagements that are doing the same thing. So we were finding that it was taking something like 4 to 6 months when a project started to end up with a fully mature DevSecOps pipeline. And the ongoing sustainment of that pipeline was pretty high because of these the implementation of this automated process was a pretty tailored implementation for each application. So about 3 years ago, we sort of sat down and said, every application, regardless of what tool it's using, is going to follow basically the same process or set of processes at any given organization. You're going to build something, you're going to test it somehow and package it, you're going to deploy it, and you're going to test it. It doesn't matter if you're building a jar file to SCP it onto a server, or you're building a container image and deploying it with Helm to a Kubernetes cluster. The generic workflow is largely the same. And furthermore, a lot of the time, the implementation of those specific steps is pretty undifferentiated work. There was no reason that every DevOps engineer at the firm should Google SonarQube plus Jenkins, find the 6 lines of pipeline code that go into doing static code analysis, and copy and paste it into their Jenkins files. So we started out trying to figure out, how can we accelerate pipeline development to ease the adoption of these practices? And how can we ease the maintenance of large-scale, enterprise-level DevSecOps pipelines? And 3 years later, and more weekends than I want to admit, we have the Jenkins Templating Engine. How many people are using Jenkins or familiar with Jenkins? That's a lot of hands. So Jenkins, by default, you have a Jenkins file that goes in the source code repository, and it outlines what your pipeline is going to do. So with the Jenkins Templating Engine, the idea was, why don't we just define a pipeline, kind of like we did on this slide, in a tool-agnostic, templated way, while still giving teams the flexibility they need to choose the tools that are the best for the job. So this is what I was able to throw together sitting next to Michael yesterday as a representation of what that looks like. In the middle, you have what would be a template. They get a lot more complicated than that, but from a conceptual standpoint, you're going to do something like build, scan, deploy, and test. You can have one application that's using Docker, performing static code analysis with SonarQube, deploying it with Helm, and using Selenium for integration testing. Or you could have a second application that's building an app with Gradle, using Fortify to scan it, using Ansible to automate some deployments, and then using something like Rest Assured to test its RESTful API. The power here is that you no longer have individualized Jenkins files. You have tool-agnostic pipeline templates that can be applied at the organization level, where you get to specify what are the organizationally approved software delivery practices to get code into production, while still giving teams the flexibility that they need to choose the best tools for the job. So I have about 5 minutes. Real quick on that, I'll go over the value of it. I think I've got 5 minutes, so I might show a quick demo or open it up to questions. So what's the value of doing it this way? The first is organizational governance. So if you have 60 copied and pasted Jenkins files, you have no assurance that everyone is actually following the same process. Everyone went and implemented it in their own way, which was a significant waste of time, to be honest. So the second value there is optimizing pipeline code reuse. Like I said, there's no reason everyone should go figure out how to do SonarQube analysis in Jenkins. Like we all already know, if you Google it, it's the first result. So at Booz Allen, we're able to open source our pipeline libraries, right? So the tool-specific implementations of different steps of that pipeline are organized into what we call pipeline libraries. So if you want to do a deployment with Helm, there's a Helm library that contributes a deploy to step. So through that, we've seen pipeline development time go from 4 to 6 months to 4 to 6 days if you're leveraging tools that we've already integrated with. And if you aren't, writing a new library is the same thing as writing regular Jenkins pipeline as code. It's just a slightly different way to organize it so that you can dynamically compose your pipeline, leveraging a reusable template, instead of building individualized pipelines for each application. And then the last point, having had to support a 60 microservice system with copied and pasted Jenkins files, in my humble opinion, it is a lot easier to manage a pipeline template that outlines the business logic of your software delivery processes and then modularized tool libraries than it is to manage those 60 separate Jenkins files. So it's open source. It's on GitHub. If you're interested in it, it's called the Templating Engine plugin. There's a whole bunch of documentation. At this point, I don't know that I have time for a demo, but I'm always happy to talk if anyone's interested. So I hope that resonates for any of you.
You have 3 minutes. Go ahead and do your demo. And then we're going into break anyway, so we lose a little bit of time to break then. Sorry.
All right, I have 3 minutes. That should be enough time. So this is Jenkins. I'm going to demo a pipeline that primarily shows off the templating side of things. So there's a couple different use cases. And I'm going to go, admittedly, a little quick here to show all the different examples here. But on the top, we have a pipeline template. So nothing there is specific to a tool. It says we're going to do build, static code analysis, and then deploy to dev. Alongside your pipeline template, you get a configuration file. So instead of defining a 700-line Jenkins file for each application, you're able to define a pipeline configuration that's going to implement this template. So it's going to read a lot like your tech stack, where there's a library section that's going to pull in exactly what tools are being used to implement these different steps. So in this case, we've got a Maven application using SonarQube, Ansible for deployment, and then a Splunk library for some monitoring of the pipeline. Down below, we have an application environments definition. Everyone has different application environments and different numbers of them. So here we're able to define a dev environment, which we can use in our Ansible library for deployment. So if we click build, or actually, since we've got 3 minutes, I'll show an existing run. It's going to pull in all of these libraries, dynamically compose what that template actually means with this configuration, and then go and execute it. So if we scale that out, it's traditionally not going to be defined in the Jenkins UI. You can apply this to an entire GitHub repository or an entire GitHub organization. Right? So if I have a single application, instead of having a Jenkins file in the repository, I can pull it out into a centralized pipeline configuration repository, and I can achieve the exact same thing without giving developers access to the Jenkins file and by leveraging these modularized tool-agnostic pipelines. So the real power here is if we go to an entire GitHub organization, I can define multiple configuration files that have a hierarchical taxonomy, right? So maybe at the entire organization level, everyone's using SonarQube, so I can define everyone has to use SonarQube and then give teams the flexibility they need to pick what specific libraries they're using for other things. So here we've got a Gradle application. It's going to look like you would expect, Gradle, SonarQube analysis. I can go over to the Maven application, and it's going to be using Maven and SonarQube analysis. So both of these repositories and all of these jobs are leveraging the exact same pipeline template. So I know that every development team in my organization is following the same software delivery practices and that same pipeline template, and then we're giving teams the flexibility they need, if you want to, because governance is the dial and the framework, to choose the best tools for the job. So like I said, I think I'm out of time, but I'm more than happy to talk in the hallway track if this resonates with anybody.
Thank you very much. Big round of applause.